everyone. Today's lesson is on what's called complex numbers, and this links very well with what we did yesterday with imaginary numbers. Okay, so most of the math that you're going to see here is not really all that new, but we do have a new definition for you here. So complex numbers are really just numbers that are made up of a real and an imaginary component. And these aren't going to look like the numbers that you're used to. Usually we think of numbers as like a single digit or a group of digits. But with complex numbers, our numbers are actually going to be in this form. It's going to be like something plus something else, okay? And when we do that, when we have a number that looks like this is called the real component because this is a real number since it doesn't have I on it. And this is an imaginary component. And when you take the real and the imaginary and you put them together, that's what gives you a complex number, okay? So like down here, when I look at example 1 and I see that 2 plus 3i, that is considered to be a single complex number. And then we can do different operations with them. We can add them, subtract them, all that stuff. But really, just like yesterday, when we're doing all this math, like you see in example 1, we're going to treat the i's just like we would treat x's in other algebraic problems. So in that first one where I see 2 plus 3i plus negative 7 plus 2i, those are in parentheses, kind of to group them and show like that this is a complex number and this is a complex number. But because I'm just adding them, I don't actually even need the parentheses. I'm just combining like terms. So 2 plus negative 7 gives me negative 5. And 3i plus 2i gives me 5i. And that's just it. I can't combine those two things because they're not like terms, so I'm just going to leave my answer right there. In the next one, it's going to be really similar, except because this is subtraction, that subtraction, remember, needs to apply to both of these things in here. So that negative sign really gets distributed. And so we have this, 5 minus 6i minus 4, and then minus 2i. So that minus sign applies to both of those things. And then I'm going to combine like terms just like I did a second ago. So 5 and negative 4 make 1. And negative 6i minus 2i make negative 8i. By the way, the biggest mistake I see with questions like those first two are people see the two parentheses and they immediately want to start foiling. You have to pay attention to what's going on in between the parentheses. So this one is addition, this one is subtraction. However, if you look down at like this last one here where you have the two parentheses right next to each other, that is where you're going to do some FOIL. You're going to be multiplying them together that way. But let's get to that example 3 first. In example 3, I'm just distributing. Okay, so I'm multiplying here and here. That's going to give me 12i plus 2i times 4i. Well, 2 times 4 would make 8, and I times I is I squared. And then what we have to keep in mind is that that I squared is going to turn that plus 8 into a minus 8. Okay, so plus 8i squared really becomes a negative 8 because remember from yesterday, I squared is equal to negative 1. And then I would probably just take this thing and write it back in the correct order with the real number first. So I would write it as negative 8 plus 12i. So once this piece turns back into a real number, we're going to put it in front. Okay. On that last one, like I said, we're going to FOIL here because that's multiplication. Oh, excuse me. So I'm going to go 4 times 6 is 24. 4 times 7i is 28i. Negative 3i times 6 is negative 18i. And negative 3i times 7i, well, negative 3 times 7 is negative 21. And I times I is I squared. So this time I have 4 pieces to work with. I'm going to combine whatever I can. So that would include these two, right? 28i and minus 18i would give me a 10i. Okay. And then I also need to remember that this minus 21i squared, that's really like negative 21 times negative 1, otherwise known as plus 21. And then I can combine that with the 24. So as far as the final answer goes, I would say 21 and 24 make 45. And then my i's came together and made 10i. So that's it. That's my final answer, and those are the types of questions that you're going to see on the back of your homework assignment. I'm going to point this out because some of you are going to have a hard time finding which ones to line them up with. Okay, so down to another term here, complex conjugate, and let me zoom that a little bit so you can see that word. Complex conjugate sounds a lot more complicated than it really is. It's just taking a complex number and switching the sign in the middle. So like this plus sign here, we would turn it into a minus sign, okay? And in the example I'm given, 3 plus 4i, the conjugate would be 3 minus 4i. That's all it means to do, is take that number and switch the sign in the middle. And so you're probably asking yourself this question right here, but why? Why would I want to do that? What good does that do me? Okay, so I'm going to answer part of that question now and part of that question in the next example, but I want you to watch what happens when I multiply something by its conjugate. So I'm going to multiply these two things together. So I'm going to do 3 plus 4i times 3 minus 4i. And in this case, when I say multiply, I mean I'm going to have to use FOIL because those are both binomials, right? So 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is 12i. And 4i times negative 4i. Well, that's 4 times 4 is negative 16. And I times I is I squared. And so I know that this negative 16i squared is going to become just a plus 16, and then I can combine it with the 9, so that's going to give me a 25. When I go to combine these i's in the middle, what you should notice is they cancel out, and that is going to happen every single time you use a conjugate. That's the important thing about using a conjugate, is those I terms in the middle drop out, and so you'll notice what I'm left with is just a regular whole number. Okay. Now, I did have to go through this process to get that whole number. You know, it's not like I can just look at this and start canceling out i's, all right? But every single time you do this with a conjugate, you should come down to a single number answer, and the important part about this is that it's a real number. It's not imaginary anymore. We got rid of our i's, okay? So that being said, let's take a look at the last example here, example 3. And for you, I think it's right on that same page with you. Okay. I went from example 1 to example 3. Kind of weird. Okay, so here we have a fraction, all right? And you'll notice there are i's on the top and on the bottom. And I want to point out, you cannot go through and start simplifying pieces of this fraction. I cannot do 2 over 6 or 3 over 7 and simplify those individually because I can't get rid of this addition using division, right? Addition and division are not opposites of each other. So you can't like draw a line down the middle and simplify them separately, okay? So the question is, what about this even needs simplifying, right? There's nothing here that you see that needs to be reduced. The problem is we have this I down here on the bottom of the fraction. And remember that I really represents a square root. And I don't remember how much of this you might remember from geometry. But in geometry, we talked about like if you do some sort of problem and you end up with a square root on the bottom of the fraction, this is not allowed, okay? And so we have to do something to that called rationalizing. You don't want any square roots on the bottoms of your fractions. And the problem here is that an I really represents a square root. So we have to somehow do something to this that's going to make it not have an I on the bottom. And that's where that conjugate thing comes in, is we talked about multiplying by a conjugate makes the I part go away. So I'm going to multiply by the conjugate of the bottom. I'm going to multiply by 6 plus 7i. Now, in order to be fair here and to keep all of my values balanced, I have to multiply by that exact same thing up on the top. Because if I do, then essentially what that pink thing represents, that whole thing, is a 1, right? Anything out over itself is just 1, and I can multiply by 1 all day long. So I'm allowed to do this. Now to actually do it, I need to use FOIL. So I'm kind of thinking of these two in parentheses. 2 times 6 is 12. Oh, sorry, that's a negative 2. So negative 12. Negative 2 times 7i is negative 14i. 3i times 6 is 18i. And 3i times 7i, well, 3 times 7 is 21. I times I is I squared. Okay, I know I can clean that up, but I'm going to go ahead and do the bottom first. And then I'll do all the cleanup at once. 6 times 6, starting out here, is 36. 6 times 7i is 42i. Negative 7i times 6 is negative 42i. And so I can see right now that those I terms are ready to cancel out. That's good. That's the whole point of doing this, is to make that happen. And then negative 7i times 7i makes negative 49i squared. All right, and simplifying wise now, I'm going to take my I squareds and deal with them. So this plus 21i squared is going to be a minus 21. Minus 49i squared is going to be a plus 49. And then I'm going to combine with these numbers over here. Okay. So up on top, negative 12 minus 21 makes negative 33. I'm also going to combine the I values in the middle here. So I'm going to go negative 14 plus 18. So that's really like 18 minus 14, or 4i, over, and then same thing here. So 49 and 36, let's see, that makes 85. And then what should happen here, because I used a conjugate, is these I terms in the middle should cancel out, and they do. So I'm left with just an 85 on the bottom, and then this is my simplified answer, okay? Okay, I think that's about it for this lesson. You should be good to go to give 6-9 a try. Good luck, and we'll go over this in class tomorrow.